Imagine someone in your family is suffering from a stomachache, and it's not just a normal stomachache. It's pretty sure that they have eaten a lot. It is due to overeating. So now, what will you suggest him or her? Will you suggest lemon juice or vinegar or baking soda solution? What will be the solution to this problem? So I have an answer. Baking soda solution is the only solution in this case, because it's the only remedy in this case, as it is basic in nature and will neutralize the excess stomach acid, unlike lemon juice or vinegar, which are acidic and would worsen the condition. Okay, so whatever is happening in the stomach of this person, it's happening due to the excess acids, right? Now, when there is already an excess of acid and you put some different acid, like in this case lemon juice, or we talked about vinegar, so they already have acid. Now acid plus acid can actually worsen the condition. On the other hand, baking soda is basic in nature, and when it is a basic thing, there is an acid already present, it can neutralize it, and neutralization is what we want in this case. So in this case, baking soda solution is the answer. Now, you must have seen that when some curry or anything falls on your shirt, in this case it's a white shirt, it's actually very dangerous because often the stains don't go, right? So it becomes reddish brown when soap, which is basic in nature, is scrubbed on it. Okay, so it becomes a little reddish brown when soap is added on it, and soap is basic in nature. Okay, now on this regard, one thing you need to remember, that turmeric is a natural indicator. So in this case, the turmeric which is present in the curry, it's a natural indicator, and soap in this case will actually turn it reddish brown. But it turns yellow again when the cloth is washed with plenty of water. Now why? Why when plenty of water is applied, it becomes white? Because water is a neutralizer. So we talked about how neutralizing the effect is very important, and in this case water acts as a neutralizer, which means it will be again turning back to yellow. Now obviously you need a soap or detergent powder to remove that. Often it doesn't remove also in case of such a light colored cloth like white cloth in this case. So but initially soap makes it reddish brown, water will neutralize and bring it back to its original condition. Okay. Now we will be talking about another natural indicator which we already have learnt about, and that is the litmus. Okay, we have talked about litmus paper in previous videos and previous class. So another natural indicator is litmus, which is obtained from lichen, a plant belonging to the division Thallophyta. Okay, so litmus is another litmus paper you can see here on this side, and this is the plant we are talking about. It's Thallophyta group, Thallophyta division, and it's lichen, the plant. Now acids are sour in taste and change the color of blue litmus to red, and bases are bitter in taste and change the color of red litmus to blue. Now this is something which you already know, but just try to revise once more. Acids will change blue litmus to red. If it's already red, it will remain red. Okay, and bases are bitter in taste and change the color of red litmus to blue, and if it's already blue, it will remain blue. Okay. So now a question for you before we proceed to the next slide. Litmus is obtained from a plant called, and we have a dash. So what is that plant? Option A, we have lunaria. Option B, we have lupine. Option C, we have lichen. The correct answer is lichen. We talked about it's a plant from the Thallophyta division, and from that litmus paper that we use to test acids or bases is obtained. Okay. Now, okay. So now we will be doing a test of acid and base. So we have different solutions here. First of all, HCl, then we have H2SO4, HNO3, CH3COOH, NaOH, CaOH2, KOH, MgOH2 and NH4OH. So different solutions we have. We will be testing whether they are acids or bases. Now the first thing is we will be testing by litmus paper, of course, and litmus, as you know, red litmus, red will be for acids and blue will be for bases. Okay, so let's do it. Now we have the solution on this side. red litmus, blue litmus. So I am not explaining about red litmus and blue litmus a lot because we already know. So in case of hydrochloric acid, that is HCl, there will be no change. Okay, so red litmus will remain red and blue litmus will turn into red because we know that it's an acid. It's an acid. What is the reason? It's an acid, which is why blue will turn into red, red will remain red. Similarly, for sulfuric acid, again it will be the same thing, red remaining red, blue turning into red. The key word here being acid, hydrochloric acid, sulfuric acid, then we have nitric acid, and the same thing happens in case of nitric acid. In case of acetic acid also, the same thing happens. Now we come to a base. Okay, sodium hydroxide, that is NaOH, and that's a base, which is why red litmus will turn into blue and blue litmus will remain blue. Okay, you see, for all the acids there was a similar pattern. Okay, as we already know, red will be remaining red, blue will be turning red. But once we come to a base, from here on we will be having all bases. I am going to the next one also. But for bases, red will turn into blue, blue will remain blue. Okay. Similarly, calcium hydroxide, same thing happens. Then we have potassium hydroxide. Okay, same thing happens. Then we have magnesium hydroxide, for which also same thing happens. So for all the acids, one thing happens, red remains red, blue turns red, and for all the bases, red turns blue, blue remains blue. So for ammonium hydroxide also, it's the same. You can see turns blue and no change. So what did we infer? If you see, for the first group, like all the acids till here, and here we start with the base. So for all the acid, there is a similar thing. For all the bases, there is a similar thing. For all the acids, red remains red, blue turns red, and for all the bases, red turns blue, blue remains blue. Okay. Now we come to two other things. Okay, that is phenolphthalein and methyl orange. Okay, so phenolphthalein and methyl orange will actually showcase different categories. Okay, first of all, phenolphthalein will turn colorless. Okay, so what will happen when it's a base, that we will see later. But phenolphthalein, for an acid we can definitely understand it is colorless, and methyl orange for an acid it is red. Okay, so this thing you need to understand. Phenolphthalein for a solution which is an acid, that is HCl in this case, it is colorless, and for a base it's red. Do we see the similar thing for other acids? Yes, sulfuric acid, again phenolphthalein colorless, methyl orange is red. Then again nitric acid, colorless and red. Then again we have acetic acid, okay, colorless and red. This is the trend. Now let's see what happens when we come to a base. Okay, so for a base like sodium hydroxide, phenolphthalein, which is colorless in case of an acid, turns pink, and which is methyl orange. Methyl orange is red in case of an acid, it turns yellow in case of, any kind of base. In this case it's sodium hydroxide to begin with. We'll see the different ones too. You see calcium hydroxide also, it's the same, pink and yellow. For potassium hydroxide also it's pink and yellow. For magnesium hydroxide also it's pink and yellow. And finally for ammonium hydroxide also it's pink and yellow. So blue litmus, red litmus we saw, we already knew, but in case of phenolphthalein and methyl orange we didn't have an idea. So here we made an idea. So first of all let me mark the acids. So till acetic acid we have all the acids, and from NaOH, sodium hydroxide, we have all the bases. So you can see in both the cases, for acids phenolphthalein will change to colorless, it will be colorless, and methyl orange will turn red. Okay, and for bases phenolphthalein, which was colorless, will turn pink, and methyl orange, which was red, will turn yellow. So this is the difference. Okay. Now very interesting thing, try to see. We have taken papers here and we are keeping some onions inside them. Okay. Those onions are now wrapped. You can see the onions are wrapped. Now they will be kept in the freezer. So after some time, after 1 hour, you can take a day also. It is kept into two different acids and bases. The paper is first of all removed. Now the onion is taken. It's in a similar condition. It was removed to show that, and now it is put in these acids and bases. After some time, when you try to smell it, you will find that it is smelling something different. Okay. So in one case it will be smelling, and one case it will not be smelling. There may be a change. What's the change? So you can see in case of onion, when it was an acid, it is retaining its smell. You know how onion smells, right? So in case of acid, it's retaining its smell, but in case of a base, it's losing its smell. So first of all, you need to understand these are called olfactory indicators. I will be completely explaining what is an olfactory indicator, but first of all, you need to understand that it's related to smell, that you can definitely understand. So there are two more olfactory indicators we will be talking about. So let's see. First of all, there is vanilla extract. Vanilla extract, you know, like it's often used in bakeries while baking cakes or cookies. You know it's a very good smell. Okay. So now, when it's used in hydrochloric acid and sodium hydroxide, we already talked about hydrochloric acid is an acid. Of course, with the name of acid, it will be an acid, and sodium hydroxide is a base. So vanilla extract, when it is when some amount of acid and base is dropped into it, what happens? So in case of acid, it will be retaining its smell. Okay, so often you can understand now that vanilla can be used with acid, even then the smell will be retained, but in case of base, it will be losing its smell. So you can see a similar trend in case of onion also and vanilla extract. In both the cases, base is making the thing lose its smell, right? And another one, we'll be talking about clove oil. You know clove, it's also used in case of scents, oil is made out of it. So we use the similar thing, hydrochloric acid and sodium hydroxide, an acid and then base. So in this case also, does the same thing happen? Yes, in this case also the same thing happens. Clove oil also retains its smell in case of an acid and loses its smell in case of a base. Okay, now let's try to define what are olfactory indicators. So these are olfactory indicators which test for acidic or basic substances through smell. Okay, so you need to understand this happens only through smell. Only by smelling you can understand. Like at the initial stage we thought that olfactory indicators it's related to smell, but that is the meaning. Okay, in case of onion, vanilla extract or clove oil, what did you see in case of litmus or methyl orange or phenolphthalein, the things we actually studied before this? You saw there is a difference in the color. Okay, phenolphthalein changes to a particular color, litmus of course we know it changes to a particular color, and in case of methyl orange also there is a color change. But in case of onion, vanilla extract or clove oil, there is no color change or the property change. The only thing which changes is the smell. Changes in the sense for acid it remains same, base it loses its original smell. So that is what occurs. So now trying to sum up what we learned in this entire video. First of all, we talked about how we will be using baking soda solution to neutralize the acid which we get in our stomach. Like by overeating, often we have acidity. You must have heard this common term. So in that case, we will not be using an acid like lemon juice or vinegar. We will be definitely using baking soda solution, okay, which is a base. It will be neutralizing the effect. Then we talked about the different indicators. Firstly, about litmus, of course, litmus which is obtained from lichen, and in case of acid it is red, in case of bases it's blue. We talked about various acids and bases and we tested it. Similarly, we tested it for phenolphthalein also, which remains colorless in case of acids and turns pink in case of bases. And then we talked about methyl orange, which gets to be red in case of acids and yellow in case of bases. Finally, we talked about the olfactory indicators. Olfactory indicators are basically the ones which change in smell. Like onion, then vanilla extract and clove oil, they have a distinctive smell, right? So that smell is retained in case of acids and that smell just vanishes in case of bases. So this is what occurs. And these are the takeaways from this video.